So what you see in front of you is the ground frame of reference in which the rain is coming down vertically. A cyclist is at rest in this frame of reference, so the velocity of the cyclist is 0, and the angle that the rain makes with the vertical is 0 in this ground frame. Now what you see in front of you is also the cyclist frame of reference, because with respect to him, the ground is also at rest and the rain is coming down at 10 meters per second vertically. Let's give the cyclist a velocity to the right. When the cyclist starts moving to the right, what you see now is the cyclist frame of reference, because in this frame of reference, you are moving with the cyclist, and in this moving frame, the cyclist is at rest. Yes, the wheels are turning, but he is at the same spot. The road is moving backwards at 4.9 meters per second, and the hills are moving backwards, that is to the left at 4.9 meters per second, and the rain is also acquired a component to the left of 4.9 meters per second. Remember, the rain's vertical component was 10. Now the horizontal component is minus 4.9. Let's increase the cyclist velocity all the way to 10 meters per second. When the cyclist is now moving at 10 meters per second, the rain's vertical component is still the same, 10 meters per second, that is not changed. But now it has an added x component of minus 10 meters per second. So the rain appears to be coming at 45 degrees. We'll do the calculation. In fact, you can see right away, it's going to be tan inverse 1, that is 45 degrees. The minus sign refers to the fact that we have taken from the vertical, we measure clockwise as negative, anti-clockwise as positive. That is just a convention that I have chosen. Nothing special about that. You should be more interested in just the angle. Hey guys, here are 3 classic problems in relative velocity involving the direction of rainfall in different frames of reference. So what we have, the equation that we are using, the equation that we use again and again is going to be V prime is equal to V minus U. V is the velocity of the rain in the ground frame. U is the velocity of the cyclist in the ground frame. So this is V, the velocity of the rain as seen in the ground frame. U is the velocity of the cyclist as seen in the ground frame. Now, from the point of view of the cyclist, that is, if you get into the cyclist frame of reference, everything acquires an extra velocity of minus u. The road will be moving with a velocity of minus u, the hills will be moving with a velocity of minus u, and the rain will also acquire an extra velocity of minus u. So this is minus u. So in the cyclist frame of reference, the rain will be falling in this direction. Now we are measuring all angles with the vertical. So this is the vertical direction. And you see the angle that the rain makes in the ground frame is this angle. We take anti-clockwise as positive. This is the angle that the rain makes in the ground frame. In the cyclist frame, it makes this angle, and we are going to call it a negative angle because we are measuring it clockwise. That is just a convention that I have chosen. There's nothing, we can simply talk about the magnitude of the angle, and that is enough. So let us solve 3 problems using this equation. The first problem is, in the ground frame, the rain is coming down at 10 meters per second vertically, and in the ground frame, the cyclist is moving to the right at 5 meters per second. Let us take the positive x-axis to the right and the positive y-axis straight up. So the velocity of the rain in the ground frame is minus 10 j cap, and the velocity of the cyclist is 5 I cap. According to our equation, the velocity of the rain as seen in the cyclist frame of reference is V minus U. So that is equal to minus 10 j cap minus 5 I cap. Let's draw that. I'm going to draw that in yellow color. So that's going to be minus 10 j cap. Let me draw that again. Minus 10 j cap. And to that we add a minus 5 I cap. So the rain will be coming down in this direction in the cyclist frame of reference. And let's see what angle it makes with the vertical. If I call this angle theta, you can see right away that tan theta is equal to 5 by 10, that is equal to half. And so the angle theta is tan inverse half. Of course, you see in the animation that I have created, you will see this angle referred to as negative because I have taken angles anti-clockwise as positive and I have taken clockwise as negative. But you don't have to worry about the sign. Your answer is theta is equal to tan inverse half. So the first problem is this. Rain is coming down vertically at 10 meters per second in the ground frame and the cyclist has a velocity of 5 meters per second to the right. So let's give the cyclist 5 meters per second. And according to our calculation, we found that the angle that the rain makes was tan inverse 1 by 2, which is approximately 26.6 degrees. So we can take it as 27 degrees with the vertical, roughly, if you round it off to the nearest degree. The second problem is rain is coming down at 10 meters per second at an angle of 30 degrees to the vertical. This is the velocity of the rain in the ground frame. The question is, in which direction and with what velocity should a cyclist move so that in his frame of reference, the rain appears to be coming down vertical? So let's first solve this problem using common sense and then we'll use the equation. Let me take an example, a silly example. Usain Bolt is running at 10 meters per second. Let's say I am running at 10 meters per second next to him in my dreams. So with respect to me, his velocity will be 0. Now I want the rain's horizontal component to be 0 because I want the rain to be coming down vertically in my frame. Now the horizontal component of the rain, if I complete this triangle, you can see the horizontal component of the rain is 10 sine 30 degrees. That is equal to 5 meters per second. That is Vx. So if I also move with the same velocity, that is the cyclist moves at 5 meters per second in the same direction, in his frame of reference, the rain will have no horizontal velocity. It will appear to be coming down vertically with a velocity of 10 cos 30. Now let's do it from the equation point of view. We have V prime is equal to V minus U. What is V? V in our usual coordinate system, x-axis to the right, y-axis pointing up, V is going to be minus 10 cos 30 j cap, right? 10 cos 30 in the negative j cap direction, plus 10 sine 30 in the I cap direction, that is 5 I cap. So this is 5 I cap. So let's write this down. So this is equal to minus 5 root 3 j cap plus 5 I cap minus U I cap, because the cyclist moves only in the horizontal direction, has no vertical component. So that is U I cap is the velocity of the rain as seen by the cyclist, and we want this to have 0x component, which means we need 5 minus U equate to 0. So therefore U is equal to 5 meters per second. Now in the second problem, The rain is coming down at an angle of 30 degrees to the vertical at a speed of 10 meters per second. And the question was, with what velocity should the cyclist move so that in his frame of reference, the rain is coming down vertically. So we calculated that the velocity of the cyclist should be 5 meters per second to the right. So let's give the cyclist a velocity 5 meters per second. And what we see in front of us is the cyclist frame of reference. Because in the cyclist frame of reference, the hills and the road are moving backwards. So let's give this guy a velocity of 5 meters per second. And what do you see? In his frame of reference, the rain is coming down vertically, just as we calculated. The hills and the road, everything is moving to the left. The rain, which had a horizontal component of +5, has now become 0 in the cyclist frame of reference. Now in this problem, rain is again coming down at 10 meters per second at an angle of 30 degrees. So the velocity, this is the velocity of the rain in the ground frame. So the velocity of the rain in the ground frame is minus 10 cos 30 j cap plus 10 sin 30 I cap. In the usual coordinate system, x-axis to the right, y-axis straight up. The cyclist velocity is given as minus 10 I cap. And the question is, at what angle is the rain coming down in the cyclist frame of reference? In the cyclist frame of reference, the velocity of the rain is v minus u. So that will be minus 5 root 3 j cap plus 5 I cap, that is v, minus u becomes plus 10 I cap. So that becomes minus 5 root 3 j cap plus 15 I cap. So the velocity of the rain in the cyclist frame is going to be minus 5 root 3 j cap plus 15 I cap. So the rain is coming down in this direction. In fact, it's far more horizontal in the cyclist frame of reference. Now, this horizontal component of the rain is 15. The vertical component is 5 root 3. If I call this angle theta, you can see that tan theta is equal to opposite by adjacent. So that becomes 3 divided by root 3, which is root 3. And therefore, theta is 60 degrees. So in the cyclist frame of reference, the rain is seen to be coming at an angle of 60 degrees to the vertical. In the third problem, the rain is coming down at 10 meters per second at an angle of 30 degrees. But this time, the cyclist is moving to the left at 10 meters per second. So let's give this guy a velocity of 10 meters per second to the left. So now the rain acquires an extra velocity to the right of 10 meters per second. You see the velocity of the cyclist is minus 10 because it's to the left. And now the rain is coming down at an angle of 60 degrees to the vertical, just as we calculated. This is an animation. Actually, it's a simulation where I've used a computer program to generate these images. And this computer program calculates the angle with which the rain is coming down and shows what you see in the cyclist frame of reference for any velocity of the cyclist. For example, if I slow it down, this is the angle at which the rain is coming down, 47. I slow down the cyclist to 0. Rain is now coming down at 30. And I increase the cyclist velocity in this direction. As you can see, the rain acquires a velocity to the left until when the cyclist is moving at 10 meters per second, the rain is now coming down at an angle of minus 30. This is a simple program that I wrote in JavaScript. At some point, maybe I'll teach you how. Goodbye.